The overall conviction among most analysts is that the hypothesis of how things came to be stays a major explanation for the early seasons of the universe. The speculation joins the movement of stars, planets, and thus forward life on those planets, including ourselves. Notwithstanding its odd name, the Big Bang offers an edifying evaluation concerning what could have happened. At first, the universe was thick, in a short space more thick than a pin head, with particles thickly packed from the second a giant impact of matter and energy happened, known as the Big Bang. This event, happening billions of years ago, set up the spreading out of immense history in any event in reasonable data. It has set off developing peculiarities with the presumptions of this theory. When NASA launched the James Webb Space Telescope, the largest and most advanced space science observatory of all time, specialists estimated that its wisdom would confirm the theory of the universe's origin. Tragically, after only 1 year in space, the telescope shocked specialists with its capacity to peer so deeply into the universe's past. The James Webb Telescope's stunning limits have uncovered countless universes going as far back to a time so old that it challenges how we could decipher the universe's origins. This revelation has sparked an intense appraisal concerning what existed before the Big Bang. One critical moment in this mission happened when cosmologist Rohan Nada, working with data from the telescope, suddenly tracked down a system from just a short time after the Big Bang, making it the most far-off universe of all time. Nat's discovery sent shock waves through established specialists, highlighting the remarkable skills of the James Webb Telescope. Its enormous objective to change our perspective on the universe has just barely begun, promising to uncover dazzling insights into the earliest times of the universe's existence. This period, barely concentrated on beforehand, holds the key to grasping the development of the first stars and galaxies. The telescope's discoveries have conflicted with fundamental theory, uncovering systems with attributes outperforming past assumptions. This extraordinary surge of early worlds has ignited a storm of scientific inquiry, testing specialists to accommodate these discoveries with existing theories. As researchers catch up with these disclosures, they face key questions about the very nature of the universe and the forces that shaped its evolution. Beyond the James Webb Telescope's advantages, which are obvious, it is found 1.5 million kilometers away from Earth, safeguarded from cosmic interference and cooled to approach absolute zero by its tennis court size sun shield. The telescope integrates a large portion mirror and staggeringly delicate instruments designed to uncover details of the early universe previously secret. This period, known as the cosmic dawn, happened around 200 to 300 million years after the Big Bang, marking the moment when the first stars and galaxies began to form. The process by which this unfolded remains a subject of perfect investigation, with hypotheses ranging from the effects of dark matter and dark energy to the interactions between star-forming gas and dust. The telescope's view of galaxies from the cosmic dawn presents a unique opportunity for cosmologists to test how they might interpret these complex components. By studying these ancient systems, researchers can either confirm the validity of their current models or uncover gaps in understanding that could lead to major new discoveries. At first, the telescope was supposed to observe a few weak and small galaxies in its pilot studies. However, reality has far surpassed these assumptions. The telescope's early pictures of the distant universe revealed a wealth of galaxies with ages, sizes, and brightness levels that defied all expectations. This astonishing flood of early galaxies has sparked a race among space scientists to establish new standard records for the earliest known massive systems with new revelations emerging constantly leaving conventional experts in awe following the James Webb Telescope's disclosures. Topic specialists and observers have rushed to study the presence of these surprisingly advanced early galaxies. Some speculated that errors in the telescope's interpretation of immense observations could be responsible for these startling revelations. That said, the consensus remains that these discoveries represent a paradigm shift in how we could interpret the early universe and offer exciting glimpses into the potential for vast progress. The new revelations from the James Webb Space Telescope about galaxies have raised important questions about the nature of the universe and tested the assumptions of standard cosmological models. While some experts are examining whether these insights can be accommodated with existing theories, others suggest that they might be the first signs that the universe is much more complex and mysterious than previously envisioned. The crucial question in play is our fundamental understanding of how the universe we know arose out of primordial chaos. The early discoveries of the JWST could reshape our basic ideas of cosmic history, revealing insights not only on distant galaxies and ancient structures, but also on the very nature of our own Milky Way. As Mark McFadden, Sr., researcher for science and exploration at the European Space Agency, puts it, you build these machines not to confirm theory, but to break it. You just have no idea how it will break. The origins of the JWST can be traced back to the Space Telescope Science Institute's sky in 1985, even before the Hubble Space Telescope was launched. At that time, Weir, then head of Sky, was tasked with envisioning what might come after Hubble. Despite initial doubts, Weir and a small team began laying the groundwork for what would eventually become the James Webb Space Telescope. Unlike Hubble, which primarily captures visible light, the JWST was designed to observe in the infrared range, allowing it to peer much deeper into the universe. This capability is crucial for studying distant galaxies whose light has been stretched into the infrared due to the expansion of the universe, making them invisible to telescopes like Hubble. With its massive, cold star-like mirror, the JWST became the principal instrument for uncovering the secrets of the cosmic dawn. The need for the JWST was highlighted in 1995 when the Hubble Deep Field Observation revealed countless galaxies in what was once thought to be a void patch of sky. This discovery demonstrated the richness of the early universe and underscored the need for a telescope capable of probing much further into astronomical history. After 20 exhausting years of development and a cost of around $1 billion, the JWST was finally launched on December 25, 2021. By July 2022, it was ready to begin its most critical year of scientific observations. Early initiatives such as the Early Release Science Program and the General Observing Program were specifically designed to search for early galaxies. While initial expectations were modest, the results far exceeded them. JWST observations have tested existing models of the early universe, revealing galaxies that challenge traditional cosmological assumptions. These stunning discoveries highlight the importance of pushing the boundaries of scientific inquiry and showcase the extraordinary capabilities of cutting-edge technologies like the James Webb Space Telescope. As scientists continue to investigate JWST data, they may uncover further insights that challenge and expand our understanding of the universe. When the first data began coming in from the JWST, cosmologists eagerly awaited the results. Many had been preparing their data analysis pipelines for this moment for years. Instead of following the traditional peer review process, which usually takes months, experts chose to share their discoveries on preprint servers like AR-14, a platform for research papers that have not yet been peer-reviewed. This approach allowed a new form of peer review to take place through online. Platforms like Twitter were established. Specialists could quickly discuss findings. Rohan Nata described this process as science by press release, and the ensuing storm of discussion was both intense and remarkable. However, there were concerns about the potential drawbacks of this rapid dissemination of results. Claus Pontypool, a JWST project researcher at SkyCU, that while the fast sharing of results facilitated quick dissemination and discussion, there was also the risk of overwhelming the process. The general understanding among most specialists is that the theory of how things came to be remains the primary explanation for the early seasons of the universe. This speculation joins the development of stars, planets, and life on those planets, including ourselves. Notwithstanding its odd name, the Big Bang offers a convincing explanation for what could have occurred at the university beginnings. The universe was densely packed into a space smaller than a pin head, filled with densely packed particles. From this moment, a huge burst of matter and energy occurred, known as the Big Bang. This event, happening billions of years ago, set the unfolding of cosmic history. However, changes in scientific data have led to developing abnormalities with the assumptions of this theory when NASA launched the James Webb Space Telescope, the largest and most advanced space science observatory ever built. Analysts estimated that its observations would support the theory of the universe's origin. Tragically, after only 1 year in space, the telescope astonished specialists with its ability to peer deeply into the universe's past. The James Webb Space Telescope's amazing abilities have uncovered galaxies dating back to such ancient times that they challenge our understanding of the universe's origins. This discovery has sparked a serious examination of what might have existed before the Big Bang. The James Webb Space Telescope's discoveries have challenged long-held beliefs about the universe's beginnings and raised new questions that could reshape our understanding of cosmic history. The telescope's findings suggest that the universe may have evolved in ways that were previously unimagined. For example, the existence of galaxies at an age far earlier than previously thought has prompted astronomers to rethink the timeline for galaxy formation. These early galaxies appear far more mature than expected, showing features such as rapid star formation and complex structures, which was believed to take place much later in the universe's history. Scientists are now investigating how these early galaxies could have formed so quickly and whether their evolution could provide insights into the processes that shaped the first stars and the earliest cosmic structures. The discovery of such galaxies so early in the universe's history has implications not just for galaxy formation, but for the broader understanding of cosmic evolution, including the role of dark matter and dark energy. Moreover, the James Webb Space Telescope's ability to look deeper into space than ever before has revealed previously hidden features of the universe. These include faint signals from the very first stars that helped light up the early universe. Observing the cosmic dawn, the period when the first stars began to form and ignite, is a critical step in understanding how the universe transitioned from a dark, uniform state to the complex, structured universe we see today. Another aspect that scientists are studying closely is the role of black holes in the formation of early galaxies. The James Webb Space Telescope's detailed images suggest that supermassive black holes, which were once thought to take billions of years to form, may have developed much earlier. These findings challenge previous theories about how black holes grow and influence their surrounding environments. Some experts believe that the presence of these early black holes could be connected to the rapid growth of galaxies during the early universe as astronomers continue to analyze the data from the James Webb Space Telescope. They will undoubtedly encounter more surprises that may force them to revise the current models of cosmology. The discoveries made so far have only scratched the surface of what the telescope is capable of revealing. Every new piece of information deepens our understanding of the universe's origins and brings us closer to answering some of the most fundamental questions in science. How did the universe begin? What was there before the Big Bang? And what lies ahead for the future of cosmic exploration? The telescope's mission, still in its early stages, promises to provide further groundbreaking data that could lead to a major shift in how we understand the cosmos. With its unprecedented ability to observe distant galaxies, stars, and other celestial objects, the James Webb Space Telescope is not just a tool for testing existing theories, but also a way to break new ground in the quest to uncover the secrets of the universe. As scientists continue to study the early universe, the knowledge gained from the telescope will undoubtedly challenge existing paradigms and offer new directions for research in cosmology, astronomy, and physics. Ultimately, the discoveries made by the James Webb Space Telescope will likely provide profound insights into the nature of the universe, its origins, and its future. By revisiting some of the most fundamental questions in science, the telescope is helping to unlock a new era of cosmic exploration, where the mysteries of the universe are no longer hidden in the dark, but are being revealed one discovery at a time. The telescope's ongoing contributions to science may be the key to understanding the full extent of the universe's vastness and the forces that govern it, transforming our place in the